Hi everyone, I am Rajitha, working as Assistant Professor of Artificial Intelligence and Data Science Department in SNS College of Technology. Today, we are diving into proportional theorem proving, a key method in artificial intelligence for logical reasoning. This is part of our AI fundamental course focusing on logical reasoning. Theorem proving is like teaching a computer to solve a logic puzzle. It is a method in AI where machines prove if a statement is true or false using logic. For example, if we know all humans are mortal and Socrates is human, the computer can logically conclude Socrates is mortal. This process is the backbone of automated reasoning in AI system, helping them make decisions based on fact and the understanding theorem and logical foundation. So, what is a theorem? If it is a statement, we can prove true using logic rules. Think of axioms as the basic truth. We start with like 1 plus 1 equal to 2. Inference rules are like steps we follow to reach new conclusions. The goal is to show that a conclusion logically um, follow from given fact, ensuring the computer's reasoning is solid and reliable. And proportional logic is the language computers use for reasoning. It deals with statement called proportions that are either true or false. For example, if it training is a proportion, we use operators like and, or, not, and implies to connect these statements. So if it is training implies the ground is wet. We can logically connect the two to make decision. What is proportional theorem proving? So is about checking if a conclusion is valid based on given fact. There are three main ways to do this. One is truth table, which check every possible scenarios. Next one is inference rules, which build conclusion step by step. And resolution, which find contradiction to prove a point. Each method help computers verify if a statement logically follow from the information provided. And the truth table method is, let's look at truth table. They list all possible truth values for statement to check if a conclusion holds. For example, if it is training, the ground is wet, and it is training, the truth table shows that the ground is wet is always true when the premises are true. It is thorough but can get slow with lots of statement because the table grows huge. Inference rules are like logical types. For example, modus ponens says if it P, then Q is true, then P is true. Then Q must be true. Another rule, modus tollens, works backward. If P is false, then P must be false. These rules help computers build new truth step by step, ensuring every conclusion is logically sound. So, the resolution method is a smart way to automate theorem proving. It converts statement into a standard form, negates the conclusion, and looks for contradiction. For example, if we have P or Q and not P, resolution cancels out P and proves Q. This method is fast and widely used in AI to automate logical reasoning. So, real world applications. Proportional theorem proving powers many AI system. It is used in automated reasoning for thinking like self-driving cars, in expert system for medical diagnosis or financial planning, and in knowledge-based agent that manage huge databases. Even programming languages like Prolog rely on it to solve problem logically. So the practices to wrap up, proportional theorem proving is how AI verify truth using logic. We use truth table, inference rules, and resolution to make this happen, forming the foundation of intelligent system. Now try this. Given if it's rain, the ground is wet, and if it's raining, can you prove the ground is wet? Use modus ponens. It is straightforward So this is the mind map for propositional logic in AI, theorem, definition and basics, structure and connectors, and functionality and use cases, and limitation and foundations. Thank you.